Solve sine 2x equals 5 cosine squared for the domain 0 to 2 pi. And that's very similar to what we did back in chapter 8, except now we have more identities to use. So we look at sine 2x and we realize, okay, we have an identity for that. That is 2 sine x cosine x. And we look at 5 cosine squared. Now, while there is an identity for that, there's not one that's really needed. So I'll first just copy this one down. Remember, we never, ever, ever divide out a trig function. So we're going to move everything to one side, and then we'll factor. So we'll have 2 sine x cosine x minus 5 cosine squared of x equals 0. Now we have a common factor there, so we'll take it out. So cosine x times 2 sine x minus 5 cosine x equals 0. We can set each one of these equal to 0. Cosine x equals 0. And we'll have the 2 sine x minus 5 cosine x equals 0. And we can move that so one of them is on the other side. Let's deal with the easier one first. We have cosine x equals 0. We look at our unit circle. Cosine on the unit circle is x. If x equals 0, we're looking at a vertical line at 0, so there are two solutions there. X equals pi over 2 or 3 pi over 2. Now we can look at over here, and while I said up here we never ever divide out a trig function, if you recall from chapter 8, there's two basic ways to go about this. The easiest one is to move the cosine over to this side. Now recall, I'm not dividing it out. I'm going to divide it, but I'm not dividing it out of the equation. I'm just moving it to the other side. So if I divide by the cosine, I will get the sine over cosine. And how about at the same time, let's divide by the 2. So we'll have 5 over 2. So in essence, what we're doing is dividing by 2 cosine of x to both sides. So now we get tangent x equals 5 halves. We're looking at our unit circle. When tangent x equals 1, which is at the 45, so we're going to be looking at something like this, a steeper slope. Remember, the tangent of the angle of inclination equals the slope of the line. We have two solutions. You take out your calculator, and your calculator will type in inverse tangent of 5 halves. Let me do that. So inverse tangent of 5 divided by 2. Make sure you are in the right mode right now. You get 1.19, and the rest of the decimal say 0, 2, 8, etc. Now how do we get this other angle starting from the x-axis all the way down? Well, remember the period of tangent is pi, so we just need to add pi to it. Let me show this on the calculator. And at this point, all you need to do is hit plus, and it'll show answer plus, and then type in second pi, and we get the 4.33. So we have 1.19, 4.33. This is x is approximately equal to those. And then we have exactly equal to pi over 2 and 3 pi over 2. Now also in this section we have inequalities, and let me solve a problem dealing with an inequality as well. So what we want to do is move it so it's on one side. It doesn't matter which side you want to have it on. Do you want to have it on the right side or the left side? Just because I'll move it over here to the left side. So we'll have tan x minus 2 sine x is less than 0. Once we get our inequality with a 0 on one side, we'll change it to an equality. So we'll have tan x minus 2 sine x equals 0. Now recall, when we get to the end, this is going to tell us what we want. We want the negative values because we want this expression to be less than 0. Now let's switch this into sine x over cosine x minus 2 sine x equals 0. We can factor out the sine. So we'll have sine x times 1 over cosine x minus 2 equals 0. Set each factor equal to 0, so we'll have sine x equals 0. And then we'll have 1 over cosine x equals 2. So might as well just move it over, that 2 over at the same time. Now remember, if two fractions are equal, and we can think of this as 2 over 1. If two fractions are equal, their reciprocals are equal as long as they're not 0. So we'll get cosine x equals 1/2. Let's look at our unit circle. So cosine is x. X is going to be 1/2 about here. What are those two values? That will be pi over 3 and 5 pi over 3. Sine x equals 0. Sine is y. When y equals 0, we have this horizontal line, so we have a solution at 0 and pi. Now, our original problem was to solve the inequality. And remember, when we're dealing with the inequalities, we're going to use a number line. So let's set up our number line. Actually, I'll move it over here so it's easier to see. We're going to start with 0, and then we'll put them in order. Pi over 3. Oh, I forgot one thing. What did I forget? We cannot have undefined values on this. And I'm just going to stop.